I'm Adam Quinton,
And I'm Jared Beagley.
and we're doing the Singleton design pattern.
The purpose of the Singleton design pattern is to make absolutely certain that there is only one instance of a class, no matter how many times it is used and no matter in what parts of a project it is used. And there are three key parts to making that happen. The first is to establish one instance of the object inside the class itself. You'll need also to have a private constructor and then a public function to get the instance of the variable that has the instance of the class in it.
Here we have the frequent flyer class. This class is following the design pattern Singleton in this example. If you look at line 5, where the frequent flyer getInstance function is, you can see that it first checks if our flyer exists. If it does, then it will return the already existing OurFlyer object. If it does not, it will create a new one. This prevents unnecessary flyers from being created, since only one is needed in this usage. Because of this, there is now only one way to modify our flyer.
So our project is actually a really good example of a project that would benefit from the use of the Singleton pattern, and there are a few reasons why. First, our project is an individually used application. So in other words, there's only one person using the mobile device that's going to log in and use the homework tracking application. And then all personal information on that person is only going to belong to the one user. And it would make sense then to only have one instance of a student class where all of their personal information and classes and assignments are kept. Because of this, two student classes should never be required to coexist. And any time throughout the entire project that the student object or class is referenced, you would be using the same instance, and so it would eliminate a lot the need for passing back and forth different parameters with information regarding the individual student.
In a real-world example, consider a family going on vacation. They want to take pictures, so they need a camera. If each family member were to get their camera and bring that, it may be unnecessary. They may spend a lot of money on fancy cameras, when really all they needed to do was share one camera, since it probably wouldn't be necessary for them to be taking pictures all at the same time.
The same concept applies for our project. Because we want to have just one instance of the student and don't want to have to pass around and conglomerate all of the different parameters and items that are modified in the student class, we can create just one instance inside of the student class and make it a private static student, as you can see here, and then make the constructor itself private, and then make a public static function to be able to get that one instance that we declared earlier of the student. That way, if there is no student to begin with, then it creates a new student, and then it'll return that one instance. So every modification made will affect just the one instance and will be global in essence.
Let's explore the upsides to using the Singleton design pattern. A single instance of the class keeps things simple. Passing class data is very easy. One only needs to pass the class instead of all of its members. Memory consumption is kept at a minimum, and the class is essentially global, allowing use of it almost anywhere.
There are some downsides as well to using the Singleton design pattern. First of all, it's not always thread safe. So in other words, if you're using it on multiple threads and have access to the same instance of the class, then one modification might not be done in the order that you expect it to be done in. This would also apply to our example with the cameras. You have one person who wants to take a picture on the left of some scenery, and then one person who wants to take a picture on the right at the same time. If you only have one camera, then taking a picture of both would become nearly impossible. Also, there's a potential to rely too heavily upon the pattern when another fits better. In other words, the singleton pattern becomes the hammer and everything starts to look like a nail, no matter whether it's a screw or not. Also, another downside to the singleton pattern is that when you have the one instance of the object, if it is not needed at a later point during the project, the instance is not taken care of. It is always sticking around in memory.
To go over what we said in the downside slide about the singleton pattern not always being thread safe, this can be easily fixed by adding the word synchronized onto the getInstance method.
We would recommend using the singleton design pattern when you have an object that you really only have need of one instance of, and that the qualifiers are something that you're wanting to pass around amongst the different locations that reference that instance. Also, if memory is scarce, the singleton pattern is good on memory, as well as when access to an object is required throughout the entire project, you will be able to use the singleton pattern to make it easy for different parts of the project to reference the object.
Let's look at some cases for good usage of the singleton design pattern. We want to use this pattern whenever we have exactly one instance of a class and we want it to be accessible from a global scope. Consider a logger class. We want everyone to be able to access the logger class, and we don't want to instantiate a new object every time we want to use it. Thus, the singleton pattern makes perfect sense. Also consider a configuration object. In this instance, whenever we load and hydrate the configuration class with data, that data persists if we're using the singleton design pattern. That means that if you're using a database, that everything will be accessible from the object instead of the database each time. It could save on performance. So in short, whenever you need shared resources, the singleton design pattern is a good pattern to use.
An example of when not to use the singleton pattern would be if you were to create your own string class. Let's say you have desires to create a new string with different functionality than the current string class. And so you create it. If you were to use a singleton pattern as displayed here, you would have just one instance of the string, but then every time that you used it, you would be accessing the same instance instead of creating your own instances in different locations, and it just wouldn't make sense. The problem is that you don't need to have any of the same different properties that you're normally going to be modifying on your string object to be maintaining throughout the different usages of it. Each time you create a new string, you're going to want to start off with a very brand new, fresh instance of the class, instead of the one that you were previously using. These are our sources.